Hi everyone, today we're going to give you a quick overview of mineral characteristics and mineral identification. Some of the minerals that you're looking at here are going to be found in your reference table on page 16, and we're going to go over the characteristics that help you identify the actual names. Now this is going to be an important feature here in earth science because this is going to be a feature on your lab practical that you're going to have to take in June. Well, minerals are going to be important to us because they're the building blocks of rocks. You see this piece of granite here, all the colors and all the specks in here in the piece of granite here are all made up of minerals. So without minerals, you don't have any rocks on the planet. What's going to be important here is to be able to look at the characteristics and to be able to identify them properly. So the first characteristic that we're going to focus on is color. And I'm going to pull out a couple pieces of quartz here just to show you that color is going to vary pretty regularly from sample to sample. You see that piece of quartz right here? You see that they're all going to come in a multitude of colors. You also have some pieces of calcite here as well. Calcite is also another sample that comes in a variety of colors. So color is not a very good identifying property because it's going to vary regularly from sample to sample. There are a couple samples though in this pile that do use color to help identify. And the first one is going to be olivine. Real good way to remember olivine is that olivine is olive green. The second sample is going to be sulfur. Sulfur in many cases is going to come in a bright yellow and also smells like rotten eggs. So that's going to be a good way to help identify those two mineral samples. The second characteristic is going to be luster. There's going to be two lusters that you're going to need to know. You're going to need to know metallic and non-metallic. Mineral samples that are metallic are going to look like a piece of metal, such as this piece of pyrite. Actually, I have a couple pieces of pyrite here. They're going to have that nice metallic look to them. I have a piece of hematite and a piece of galena. So you have to be careful because a lot of these are going to look shiny. Just be careful with the characteristic of shiny because you can have non-metallic minerals that are shiny. So these are going to look like pieces of metal. If they look like a piece of metal, they're going to be metallic. Now non-metallic, it doesn't look like a piece of metal. So I'll put a piece of quartz up there. Okay, so a couple pieces of quartz. You'll see that they look a little shiny. Okay, much like with your calcite as well. They can be shiny, but if they don't look like a piece of metal, they're going to be non-metallic. Piece of olivine. I'll also put out a piece of hematite that's non-metallic as well. You see they have a very dull earthy color, some of them. Like these two have very dull earthy colors. These guys are a little bit more shiny, but they're going to be non-metallic. They don't look like a piece of metal. The next characteristic that we're going to get into is going to be streak. So I'm going to actually put out two streak plates, which are basically going to be two unglazed porcelain tiles. And what you're going to do here is you're going to take the mineral and you're going to get the powdered version of it. So for instance, you can take a mineral sample and just run it across the streak plate, and what will happen is you'll get the powdered version. It's a very reliable property because every mineral sample is going to be consistent with its streak color. So for instance, what I just rubbed on the white streak plate was your non-metallic hematite. If I take the metallic hematite and do the exact same thing, it doesn't come out as prominent, but it's still going to come out with some sort of a red tinted streak, much like the non-metallic version came up with. Now some minerals are going to produce darker streaks and other minerals are going to produce lighter streaks, such as calcite comes up with a little bit of a white streak. Quartz is going to come up almost a white to no streak at all. You can get sulfur, which is going to come up with a yellow streak. Now the reason why I have two, you're going to use the darker minerals on the light streak plate, you're going to use the lighter minerals on the dark streak plate. And what that does, it gives you a little bit of contrast with your streak colors. The next test is going to be your hardness test. And what we like to do is we like to take a piece of glass and we like to take these minerals and we like to put them against the glass to see if they're going to scratch it. Glass has a hardness of 5.5 on Mohs hardness scale. So if a mineral like quartz is harder than glass, it's going to scratch it. Okay, one thing you want to listen to is if it's going to scratch it. Sometimes it's hard to see the scratch on the glass, but you can hear the mineral actually scratching, and you can see a very prominent scratch in the glass there. So quartz, for instance, is going to be harder than 5.5. You take galena. Okay, galena, you're not going to hear any kind of scratch in the glass. No matter how much you're going to move that against glass, it's not going to scratch it. Galena actually has a hardness of about 2.5. It's not going to scratch your glass. So we keep it kind of simple here in earth science by taking the mineral. If it scratches glass, it's harder than 5.5. If it doesn't scratch glass, it's going to be softer than 5.5. Now every mineral up here is going to have a individual look. It's going to have individual characteristics that's all based upon the internal arrangement of atoms, whether it's the color of the mineral, the streak color, whether it has cleavage or fracture. It's all going to be based upon the internal arrangement of atoms. Now, I'd mentioned about cleavage or fracture. That's how a mineral is going to break. Now, there's going to be two ways in which a mineral breaks. It's going to break along flat, even sides, much like your calcite here. I have a piece of halite. You see the nice flat surfaces. Okay, here's another piece of halite. Okay, you're going to have some minerals that are going to break along flat surfaces. An easy way to try to identify cleavage planes is I like to put the mineral in between my thumb and my forefinger. If my thumb and forefinger are on flat parallel sides, you're dealing with cleavage planes. Now, calcite, for instance, has a multitude of cleavage planes. It has one, it has two, it actually has three different cleavage planes within it. And when this mineral is going to break, it's going to break in along those flat planes because of its internal arrangement of atoms. So if it has flat parallel sides, much like your halite pieces and your calcite piece here, it's going to have cleavage. Unlike fracture, which is uneven. So for instance, this piece of hematite has fracture. There's no flat parallel surfaces. Sulfur doesn't have any flat parallel surfaces, so it's going to have fracture. You're going to have pyrite. Again, no flat parallel sides to it, so it's a very uneven break. Olivine is going to have fracture, very uneven surface. And you can also say quartz as well has uneven surfaces. These are all considered to have fracture, unlike your other minerals like calcite is going to have cleavage. So you have distinctly different ways in which a mineral is actually going to break. Now, the last thing that we want to talk about is some of the special properties here. So one of the special properties that your minerals are going to have, calcite, for instance, has a property called double refraction. If I move this piece of calcite over top of the word calcite, you'll see that it'll actually double up. So that's what we call double refraction. Magnetite is a metallic mineral that exhibits special property called magnetism. So it's actually semi-magnetic here. It's probably been dropped a couple times, so the magnetism is not that strong, but you still see it has a little bit of magnetism to it. So it's naturally magnetic. That's where it gets its name, magnetite. And if I take this piece of calcite and I put a little bit of hydrochloric acid on it, what will happen is the hydrochloric acid will actually react and produce a bubbling or fizzing of the actual mineral itself. So you can see the bubbling going on there with the hydrochloric acid. That's an easy way not only to identify calcite, but to also identify the rocks that are made of calcite, such as limestone and marble. So with that being said, good luck with your mineral characteristics, and we'll talk to you soon.